When we look up at the night sky, it's always there, silent, constant, familiar. The moon. For thousands of years, it has inspired poems, myths, and prayers. But for science, the moon holds something far more profound, perhaps the oldest secret of our planet. At first glance, it seems like a simple satellite, yet the moon is astonishingly similar to Earth. Its rocks, minerals, even isotope ratios almost identical. That led scientists to a haunting question. If the moon is so much like Earth, could it have been born from it? Since the 1970s, research has pointed to one extraordinary possibility. Around 4.5 billion years ago, when the solar system was young and chaotic, the early Earth was still forming, its surface molten and unstable. And somewhere out there, a Mars-sized planet named Theia was slowly drifting toward us. Theia, a lost world once orbiting the sun like Earth, destined for a collision that would change everything and give birth to the moon. But how could such a cosmic impact happen? And why, billions of years later, do traces of that ancient collision still remain in both the Earth and the moon? Next, we'll travel back to the violent dawn of the solar system, a time when planets crashed, magma oceans boiled, and the moon's story began. Before continuing, don't forget to subscribe and like. This really helps the channel grow. And tell us in the comments, what kind of space stories would you like to see in the next episode? 4.5 billion years ago, the Earth was nothing like the calm blue planet we know today. Back then, it was a fiery world, an ocean of molten rock swirling beneath a toxic atmosphere. Asteroids and comets rained down endlessly, reshaping the surface over and over again. In that chaos, the young Earth was still growing. Each collision added more mass, more heat. The planet's crust couldn't form properly, and every few thousand years it melted again. Volcanoes erupted across its surface, and space itself glowed with drifting debris. And somewhere beyond, another world was forming, Theia. Roughly the size of Mars, Theia orbited close to Earth's path around the sun. For millions of years, their orbits danced dangerously near one another. Gravity pulled at both worlds, slowly twisting their paths until fate brought them closer and closer. This wasn't a small encounter, it was inevitable destruction. When Theia finally struck, the collision released more energy than any explosion in the universe since the Big Bang. It melted both worlds, sending clouds of molten rock into space, a glowing ring of debris that would soon become the moon. But before that happened, Earth itself had to survive. Could our young planet endure such a violent impact and still become the home we know today? When Theia finally collided with the young Earth, it was not a simple crash, it was a cataclysm. The impact tore through the planet's crust, vaporizing rock and metal in an instant. Mountains vanished. Oceans of magma erupted into space. For a brief moment, Earth and Theia became one, a swirling, molten body of chaos. Chunks of molten rock, some the size of continents, were thrown into orbit. They glowed like miniature suns, forming a fiery halo around the remains of Earth. Within weeks, this glowing ring of debris began to cool and gather together, small fragments clumping into larger ones, guided by gravity's invisible hand. From that cosmic wreckage, a new world was born, the moon. It started as a glowing sphere, orbiting much closer to Earth than it does today. Back then, it would have filled the night sky, 50 times larger than we see it now. Scientists believe this giant impact hypothesis best explains the moon's composition. Moon rocks brought back by Apollo astronauts are nearly identical to Earth's crust, showing that both worlds were once part of the same molten body. That connection means something profound. Our moon isn't just a satellite, it's a piece of Earth itself, a scar left from the most violent birth in our planet's history. After the colossal impact, Earth was a glowing sphere of molten rock, a world on fire. The sky was filled with vaporized stone and metal, forming a dense cloud that blocked sunlight. For months, maybe even years, the planet remained wrapped in a fiery haze, but slowly, as the chaos faded, the surface began to cool. Molten oceans solidified into crust, the air thinned and calmed, and the moon, once glowing red-hot, started to harden too. Both worlds settled into a new rhythm, bound together by gravity's pull. In those early days, the moon was much closer, so close that its gravity churned Earth's surface, creating massive tides that shaped our young oceans. Meanwhile, the moon itself was locked by that same gravity, showing us the same face it does today, the tidal locking that would define our nights forever. As the Earth cooled and stabilized, something incredible began. Life's first conditions were taking shape. The chaos that once threatened the planet had, in a way, created balance. And that balance, yet between Earth and Moon, would set the stage for everything that followed. For decades, scientists debated how the Moon came to be. Was it captured by Earth's gravity? Or did they form together from the same cloud of dust? None of those theories fit perfectly until the giant impact hypothesis emerged. The turning point came when researchers examined lunar rock samples brought back by the Apollo missions. To everyone's surprise, those rocks were almost chemically identical to Earth's crust. That meant the Moon wasn't a foreign body. It was made of the same material as our planet. If Theia really existed, its collision would have blasted Earth's outer layers into orbit. Over time, those pieces gathered and cooled, forming the Moon we know. Computer simulations confirm that such an impact could explain the Moon's size, orbit, and composition far better than any other theory. Even today, traces of Theia might still be deep inside Earth's mantle. Giant, dense regions detected by seismic waves that could be the planet's buried scars from that ancient collision. Every rock on the Moon tells a part of that story. A 4.5 billion-year-old reminder of the day two worlds became one. Theia's impact didn't just create the Moon. It transformed Earth forever. When the two worlds collided, the young planet was nearly destroyed. But what rose from the chaos was something entirely new. That massive collision melted Earth's surface, turning it into a global ocean of magma. Heavy elements like iron and nickel sank to the core, forming the planet's powerful magnetic field. A shield that would later protect life from deadly solar radiation. Lighter materials rose and cooled, becoming the foundation of the crust we stand on today. And then, the Moon began to play its quiet but vital role. Its gravitational pull stabilized Earth's tilt, creating predictable seasons and a steady climate, crucial for the evolution of complex life. Without the Moon's balance, Earth might have been a chaotic world of extreme shifts, making life as we know it impossible. Some scientists even believe the Moon's tidal forces helped stir the oceans, driving the chemical reactions that led to life's first spark. So, in a way, we owe our very existence to that ancient, catastrophic encounter. Theia may be gone, but her legacy lives in every sunrise, every tide, and every heartbeat on this blue planet. If Theia really existed, where's it now? That question has haunted scientists for decades. Some believe Theia was completely destroyed in the collision, vaporized and scattered into space, leaving behind only the Moon as its silent monument. But others think Theia never truly vanished. Deep beneath our feet, in the mantle of the Earth, scientists have discovered two massive regions, one beneath Africa and another under the Pacific Ocean. These mysterious zones, called LSVPS, large low shear velocity provinces, are made of unusually dense material. Some researchers suspect these are the buried remains of Theia, fused into Earth itself during the impact. Recent simulations using supercomputers support this idea. They show that a collision the size of Theia's could have mixed the two planets so completely that parts of Theia became a permanent part of Earth's interior. If that's true, Theia isn't lost. She's still here, forming the very bones of our world. Future missions studying lunar samples and Earth's deep geology may finally confirm it. And when that happens, we'll know that our planet carries within it the remains of another. Two worlds, forever joined by one incredible event. The story of Theia isn't just about a collision. It's about creation through destruction. From chaos came balance. From impact came the Earth and Moon, bound together in a cosmic dance that continues today. Every sunrise, every tide, every lunar eclipse is a reminder of that ancient event. Without Theia, our days might be shorter, our planet less stable, and life as we know it might never have evolved. The Moon's pull slows Earth's rotation, steadies its tilt, and shapes the rhythm of our oceans. All thanks to that one violent moment billions of years ago. Theia may no longer exist as a separate planet, but her legacy is written in every beam of moonlight. She became part of Earth, shaping the cradle of life and guiding us through the night sky. As humanity prepares to return to the Moon, we're not just visiting a distant world. We're coming home to a piece of ourselves. Because the moon isn't just Earth's companion, it's a memory, a reminder that even in destruction, the universe finds a way to create something extraordinary.